So hi guys, welcome to the second part of the um, video on circle theorems. We looked at 4 theorems so far. We looked at the fact that angles in the same segment are equal. We looked at the fact that angles at the center is twice angle at the circumference. And then we looked at angles in the semicircle is 90. And then we looked at the fact that opposite angles in the cyclic quadrilateral are equal. So that's what we looked at so far. So we'll go a bit further now and take the remaining theorems. Okay, so let me just share my screen quickly. Okay, so the remaining theorems we'll be talking about are theorems that have to do with tangent. So the first thing I want to look at is what's a tangent. What exactly is a tangent? Okay, you come across tangents in maths a lot. You still see it in when you do normal graphs. They tell you to draw a tangent to cover at a particular point. That will be available in another video. Okay. So this is what you have. Yeah, so this is a tangent. So a tangent is a line that touches a circle at just one point. It never enters into the circle. It will just be at the body of the circle at one point. Okay, you can also have another tangent like this, but it will never go to the circle. It will just touch the circle at just one point. Okay, so you can have as many tangents as possible. Okay, so the remaining theorems we'll be talking about are theorems that have to do with a tangent to the circle. Okay, so let's get to it. So we've done 4 theorems, so let's go to theorem 5. Sorry about this. Let's go to theorem 5. Theorem 5. Okay. Now, what theorem 5 is saying is that, let me draw the diagram first, then I will illustrate it. This is a circle, then this is a tangent here, right? Draw it properly. So this is a tangent to that circle. Okay. Now this is the center of the circle. And then there's a line that goes like this to the circle, right? Okay. So the first theorem is that this is the center of the circle. So the first theorem is that the line from the center to the tangent is 90 degrees. Or basically, you can just say that the radius makes 90 degrees with the tangent. So the radius makes 90 degrees with the tangent. That is theorem 5, okay? So it could be in any way. Let me try and draw it to be funny looking. It can be like this. It can be like this, okay? And they now have a tangent that goes to, maybe let me draw the tangent like that. Let me just, I don't want to draw it to be odd looking, so that I don't want the tangent to be looking odd, so that I'll be able to see that it's not just one way. And this is the center of the circle, okay? So this, like this, okay? So it's the same thing. This place is also 90 degrees, okay? So that's theorem 5. Tangent to the radius and tangent makes 90 degrees, or line from tangent to the center is 90 degrees, okay? So let's go to theorem 6. Theorem 6, okay? So suppose, let me just draw the circle. So what now happens when you have not just one tangent and you have 2 tangents drawn from the same point, okay? You have a tangent that goes like this. You have another tangent that goes still from that same point. Okay? So this is P, this is R, and this is S, okay? So what are we saying about this? So what we are saying is that PR is equal to PS. And what is the statement? The statement is that tangents drawn from common points are equal from a common point. Okay, so if you have a tangent or you have 2 tangents that are drawn from the same point, those tangents are equal. You may now ask, okay, how does that affect what we are doing? So something just came to my head. I can um actually just work with this. So this is the center of the circle. You see how it applies. So if a line goes like this, right? Another line goes like this, right? I can even draw something like this. I'm just being innovative, being creative, just trying to see how it can make sense. Okay, suppose um this place is 70 and you are told to find x, for example. So what do you do? Okay, so you can see an element of theorem 5 here because we've said the radius and the tangent makes 90. So we can see that this place is 90 clearly. This place also is 90 by the same thing. This is 90, this is 90. And then we can see an element of theorem 2, the angles at the center is twice angle at the circumference. So this place is 2 times 1 times 70, which is 140. Then you cannot get x because it's now a quadrilateral. Angles on the quadrilateral is 360. So you can just say 360 minus 90 plus 140 plus 90. And then you get your answer. Okay, I must confess at this point that you see, the theorems that have to do with tangent are the ones that are a bit more complicated on the exam. They are the ones that you find it difficult to get any theorem, to locate any theorem and it makes sense to you. That's just how it is, okay? So let me just go to theorem 7 so we can now take exercises. Let's look at theorem 7. Okay. Again, it's going to be based on a tangent, and this one is very, very important because this one is one of the most popular theorems on the exam. Okay, so look at this. Now, follow the statements I'm going to be making. Okay, because in the statements lie what we're about to do. Now, the first thing is that you have a tangent. So let me draw a tangent. Right? Yeah, okay, let me draw it in a simple place first before I make it complicated. Now, this is a tangent. Okay? Now, at the point where the tangent touches the circle, you draw a chord. Now, let me draw a chord here. Again, where a line that goes through the circle but does not pass through the center is a chord. It's different from a diameter, whatever the diameter is also a chord. The diameter is a chord that passes through the center. But that's not what we're looking at. But I'm just saying that the line, so the point where the tangent touches the circle, you draw a chord. Automatically, where two lines meet, an angle is formed. Let's call this angle x. Automatically, anywhere two lines meet, no matter how crooked those lines are, an angle is formed. Now, that same chord that makes an angle with the tangent, let's now assume that that same chord now has an angle, now carries another angle at the body of the circle on the other side of the circle. So this same chord now carries an angle here. And what this theorem is saying is that this angle x is equal to this place. And the theorem is called the alternate segment theorem. So that is telling you that this angle is equal to this angle because they are in different or they are in alternate segments. Okay, now let me re-explain, drawing it in a funny place. Okay, now let me start with the statements of the theorem again. Let me start with the statement of the theorem again. This is your circle, right? Okay, let me draw a tangent to the circle in a funny looking place here. At the point where the tangent touches the circle, we draw a chord. Can draw a chord like this. Can go anywhere, can even go like this. Automatically, this chord makes not even one angle, this chord makes two angles. You can pick any of the angles. Look at this angle here. This angle here. Then the same chord, this same chord now carries another angle. Let me make it stay in a funny place. Maybe somewhere like this. Doesn't have to look nice. Okay? So you are monitoring that this is the chord. So this is the angle that that chord carries. So if this is y, it means that this place also is y. In fact, let me do one better. If this place is x, this time around it is this chord that carries this one here. This one is x. By the reason of all time. segment. So we call it the alternate segment theorem. Okay, we call it the alternate segment theorem. Okay, so those are the theory. Let's stop at those theorems and then let us go and solve some questions. And then that'll be all with this video, and then the last video will be on application of circle theorems. Okay, so let's quickly look at some questions I've queued up here. Okay, now let's start with this. So you can see that there's a tangent there. Okay, so hit the pause button, and what theorem do you think will work here? What theorem do you think would work here? So for me, I can see the alternate segment theorem in action here because this place is 50. This FC now carries this chord here. You can see this is the tangent, this is the point, and this chord. The angle we are talking about will not touch the chord at all. That's how you know which angle belongs to what. The angle we are talking about will not touch the chord at all. Okay, so this place is 50. You know, we've not even looked at what they want us to find. Okay, but we can actually be assuming what the question is going to be like. Okay, so let's look at it. The question says find EFC. That is this place. Okay, so hit the pause button and try it out, but I'm sure we can already see what we are supposed to do here. So this place is 50. You can see these lines here. These lines here means that these sides are equal, so which means this place is also 50. Not this 50 here, this 50 inside here because it's an isosceles triangle. So EFC, using angles in a triangle, is just 180 minus 50 plus 50, which is 180 minus 100, which is 80. So EFC is 80. Okay, that is settled. This is 80 degrees. Then the next one says find CDE. That's the last one. Find CDE. Please hit the pause button again and try to find, let me use the red marker for EDC. Or what do you say? Or CDE, which one? Should be CDE, same thing. So this is it here. So what do we do? You can see that this is the cyclic quadrilateral. The four vertices touch the body of the circle. So you just say 180 minus 80, which gives you 100. So CDE is 100. Okay, let's go one step further. Okay, let's look at this. The question says find ACT. We are finding ACT. Let's just mark it. ACT, that's this place. Okay, so let's go step by step. Okay, so again, we have a tangent. Okay, and then because we have a tangent and then this place is here, obviously alternate segment comes in because this chord, this big chord is carrying an angle here, and this is the angle that is 98 degrees. Again, the angle that is equal, the way you know it is that that angle will not touch the chord. You can see that that 98 is not touching the chord 80 at all. Okay, so that place is 90. Okay, so I can see clearly that we can do angles on a straight line here. So 180 minus 98 gives me this as 82. Okay. So we can do something again. You will discover here that this place and this place are going to be equal because of these two lines. It means they are isosceles. So we say 180 minus 98, which is 82. 82 divided by 2 is 41. So this place is 41. Okay. So that means we can now do angles on a straight line to get these remaining parts. So this place will be also 41. Why? Because everything, these three angles must add up to 180. Okay. Then what do? We now do angles in a triangle to get this one. That's 180 minus 82 plus 41, which gives us 180 minus 123. That gives you 47 degrees. Okay. And that's how you get that. Okay, I must say at this point that when you're doing circle theorem, it's about a lot of practice. The way you just look at the shape, if you've practiced a lot and then you just see that it makes sense. Okay, so it's not magic, it's just by practice you just begin to recognize how those things work. Okay, now let's go to the next one here. The next one, I have this one queued up also. The question says find angle X. Again, if this is 53, please don't forget to hit the pause button and submit on your own and see if you get it. This place is also 53, clearly. Okay. Again, if this is angle at the body of the circle, this one is twice because it's at the center. So this is 106. Again, isosceles triangle because this is radius, this is also radius. So 180 minus 106 gives us 74. 74 divided by 2 gives us 37. So this is 37, and this is also 37. But now we can do angles in a triangle to get angle X. So we can just say 53 plus 20 plus 37 plus 37 plus X, okay? To get 180 equal to 180. So that's, if you add it properly, this is 73 plus 74 plus X is 180. So that's 147 plus X equal to 180. So X is 33. So X is 33 degrees. And that is that. Okay. And then for the final question on this, okay, let's see if the biggest lasts. Okay. The question says find DC. The first question says find angle ADC, and just make it bigger. Find angle ADC. Did I say ADC? Yes. Okay, so that's the whole of this. Okay, so what do we do? Okay, so clearly I can see a quadrilateral, so it's a cyclic quadrilateral. You can see how it's drawn. If you don't pay close attention, you won't get it. So it's a cyclic quadrilateral. So the whole of this is equal to 180 minus the whole of this. So that's 180 minus 131. That's 49. So this whole place is 49. So I can put this place as 29 because we may need it in another question because the total is the total is 49. We may need that guy in the question. Okay. And then the next one says find AOC. I beg your pardon. AOC. That's this guy here. So how do we find this guy? Remember, I told us that we can apply the second law and the third law together. And this is the case like that. So I know for a fact that 131 times 2 will give us this angle here. That's 262. But angles around the point is 360. So this AOC we are looking for is 360 minus 262. Okay, which is 98. So this place is 98. Okay, let's just keep it going. The next question is find BAT. BAT, that's this place. BAT, that's this tiny angle here. This tiny angle here, BAT. Okay, so how do we get angle BAT? Okay, don't forget to hit the pause button and then you can try it out and see what you will get. Okay, so I know that BAT is 20 because it's the alternate segment. Look at it, this is the chord and the chord carries angle 20 up here. Okay, okay, so that means it is 20 degrees. BAT is 20. BAT is 20 degrees. And the last one says OAB. 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 Okay, so that's this place. Okay. Again, you can see that we said the angle that the tangent makes with the radius is 90. And you've taken part of it as 20. So that remaining part is 70. So OAB that we are looking for is just 90 minus 20. Which gives us 70 degrees. Again, I cannot overemphasize. Second theorem is one topic where practice allows you to recognize. Practice allows you to recognize what you're supposed to see in the question. Okay? If you don't practice, there's no way you should just keep looking new to you. By practicing many examples, you will see the way IGCSE sets their papers and then you'll be able to solve it. Okay? So let's just stop there for now. Thank you for joining again. Look out for the third series on circle theorems, and that one will be application of circle theorems to area and circumference and similar triangles. Okay. Thank you for watching this video, and bye-bye.